All right, next video in Module 7, we are going to start with solving a two-step linear inequality, problem type 1. Okay, and this is actually in section 1.7 in the textbook, so we're kind of starting a new section here. So we'll have a bunch of inequalities in these next couple videos here. So the first one, it's just like linear, but you just have to remember that when you multiply or divide by a negative, remember that sign switches. Okay, so if we have like negative 21 is greater than or equal to 4x minus 9. Okay, just it's the same way as if that was an equal sign in the middle. So we're going to add 9 to both sides. So we'll have negative 12 is greater than or equal to 4x. We're going to divide by 4. And we'll have negative 3 is greater than or equal to x. And that's it. That's all you do. Just remember that you have to, if you multiply or divide by a negative value, the sign switches. So I'll see if I can find an example where that's going to happen. Actually, I don't see any showing up in this module. So maybe there'll be a different problem type here. So I'll just do another example of this one, but it should be pretty straightforward for you guys, I think. So like negative 17 greater than or equal to 3x minus 8. So add 8. We'll have negative 9 greater than or equal to 3x. Divide by 3. Negative 3 greater than or equal to x. Oh, same answer again. Different number, same answer. Okay, so that should be hopefully a nice little easy one for you guys. Now we're going to do the same thing, but it's going to be problem type 2. So this is going to get you the negatives. I was getting ahead of myself a little bit. Okay, so same thing. It's going to be solving a two-step linear inequality, problem type 2. So the only difference here is that you're going to have some negatives that you work with. Okay, so an example on this one, if we have negative 5w plus 1, less than or equal to negative 19. Okay, so subtract the 1. So negative 5w less than or equal to negative 20. Now we have to divide by negative 5. Okay, so like sirens should be going out. Oh, we're dividing by a negative, which means we're going to switch that inequality symbol around when we do that. Okay, so we're going to have w greater than or equal to 4. All right, and that's the only additional step. So hopefully you guys can kind of cruise through these. I'll give you another one here just to kind of practice. 41 less than 17 minus 6y. Subtract the 17 of positive 24 is less than negative 6y. We're going to divide by negative. Okay, which means we'll have negative 4, flip your symbol, greater than y. And that's it. Okay, you just cruise through 2 topics. Let's do the next one. We have solving a linear inequality with multiple occurrences of the variable. So this is not going to be that much more difficult. And this is also problem type 1. Okay, it's just going to be a little bit more involved here, but it's still just like algebra. You've seen this stuff. Negative 3v minus 32 is greater than 4v plus 24. Okay, so we're going to get everything to one side. So we're going to get the v's to one side and the constants to one side. And it doesn't matter which side you want to do. A lot of people like to keep that coefficient on the v positive. So they would add the 3v to both sides. So we have negative 32 is greater than 7v plus 24. and then subtract the 24. So negative 56 is greater than 7b. Divide by 7. Negative 8 is greater than b. Okay. I can get you another one there. We have 5 minus 4y greater than or equal to 13 minus 2y. Okay, so again, we usually want to keep the y's positive, so we'll add 4y to both sides. Otherwise, it's just going to be negative, and you have to remember to switch the sign around again. Okay, subtract 13. So we'll have negative 8 is greater than or equal to 2y, and then divide by 2. Negative 4 is greater than or equal to y. Okay, and you can also write it like y less than or equal to negative 4 if you want to, or here v less than negative 8, doesn't matter. Okay, let's get another one. Same thing, but problem type 2. Okay, so solving a linear inequality with multiple occurrences of the variable. Problem type 2. Okay, so they just kind of keep adding more steps here for us. Just another layer of algebra that you guys can definitely handle. You guys got this, okay? So if we have 5y minus 30 less than or equal to negative 4, 4 minus 3y. Okay, so an initial look, we would want to divide both sides by negative 4. If possible, if it went into both 5 and 30 evenly, we would do that. But it doesn't. Okay, so the next step then would just be distribute that negative 4 on its side there. So we'd have 5y minus 30 is less than or equal to negative 16 plus 12y. Okay, and that's it. So now it's just like the last one, right? Not too shabby at all. So again, we usually want to keep the y's positive, so we subtract 5y from both sides. I'm just going to show you if we didn't do that. If you said I'd rather do negative 12y, so I'll get negative 7y. I don't know why you would do that, but it's okay. And then you added 30. So you have negative 7y is less than or equal to 14. You can divide by negative 7, but just switch that sign around. So y is greater than or equal to negative 2. There you go. Okay, let me get you another one here. We are cruising. These should all be pretty straightforward, I hope, for you guys. 7x minus 36 less than or equal to negative 3 times 4 minus 5x. Okay, so again, if I could divide everything by 3 or negative 3, I would, but 7 is not divisible by 3. Okay, so just distribute that negative 3 since we can't get rid of it. It'll be negative 12 plus 15x. We're going to subtract 7x to keep the x's positive. And we're going to add the 12. So negative 24 less than or equal to 8x. Divide by 8. And negative 3 is less than or equal to x. All right. Next one. This is going to be solving inequalities with no solution, or all real numbers as solutions. Okay. So let me find a good one here for you guys. Oops. Okay. So a lot of these, well, here, I'll do. So So for example, if we had negative 2 times u plus 4 plus 38 less than 5 times 3 minus u. Okay, kind of a big mess there, but just distribute. So negative 2u minus 8 plus 38 less than 15 minus 5u. So negative 2u plus 30 less than 15 minus 5u. Add your 5u to both sides. So we'd have 3u plus 30 is less than 15. Subtract the 30. So we have 3u is less than negative 15. Divide by 3. And u is less than negative 5. Okay. So we got an answer there. So there is a solution, and that is it. Okay. But now we'll do one that actually doesn't have a solution. And then I'll try to find one that has all real numbers. So we have 5 times 4w plus 7 greater than or equal to 20w plus 36. Okay, so then we distribute that 5 and we get 20w plus 35 is greater than or equal to 20w plus 36. And you can already tell like that's not going to work. Okay, but we can simplify it down to just like before when it was linear, just an untrue expression. So if I subtract 20w from both sides, I'm left with 35 is greater than or equal to 36. And that's not true, right? This is not a true statement. 35 is never greater than or even equal to 36. So we would say that there is no solution here. Okay, let me find you guys one that has all real numbers. Let me search here quick, or I can just make one up here. They're not going to give me one. I can just make one. Okay, here's a good one. If I have 3 times 6 minus x plus 3x is less than 22. So distribute 18 minus 3x plus 3x is less than 22. 18 is less than 22. That is true. 18 is always less than 22. So we could say all real numbers work in here. Okay. All right, we are going to do another one since these are going very well. We are going to do a compound inequality. Solving a compound linear inequality. Interval notation. Okay, so you kind of want to think, you got to think about what will make both of these statements true. So an example of this one is we have 2u plus 2 is less than negative 2, or 3u minus 6 is less than negative 21. Okay, so we work on each of them separately. Okay, so we would have to have subtract 2, 2u is less than negative 4, divide by 2, u is less than negative 2, or on this side, add the 6 to both sides and divide by 3, so u is less than negative 5. Okay, notice the or there. Okay, either of those things can be true. So a lot of times we use number lines with these. So if I do a number line, and let's see, we got some negative values going on. So I'm going to do, we'll do like a 0, 1, 2, 1, negative 2. Oh, I probably got these a little too close together. Let me fix that up a little bit. Give myself more room to write here. Oh, now look what I did. Okay, it's okay. Oh my goodness. I'm a mess here. Let me just start over. Okay. Oh my gosh. Okay. 0, -1, -2, -3, -4, -5. We'll fit it on there. Okay. So if I first graph the u is less than -2, so open circle on -2, and I would have all the values that are left of it shaded. Okay, now if I were to graph the second one, and I don't want to overlap, but I'm going to do it kind of above. So open circle on -5 and shade to the left of it. Okay, since it's or, I want to take everything. So everything that I just shaded. Okay, so I would take anything u is less than -2. Okay, and that overlaps with u is less than -5. But basically, if I were to put this right on top, first of all, that open circle would be filled in by the solid line from the previous one and all the way to the left. So what I just shaded is u is less than -2. Okay, so the final answer, interval notation, I would have from -infinity to -2. We never include the infinity, so that's a curved bracket. And our inequality tells us we don't want to include the -2 either, so that's a curved bracket. Okay, so there's your answer there. Let me get another one for you, especially one that would have an and. So give me a second here. Okay, so for the next one, we have 2u minus 6 is less than -14, and 4u plus 5 is less than 21. So taking your first one, 2u would be less than -8, so u is less than -4. And your second one, 4u is less than 16, so u is less than 4. Okay, so your number line again, I'm not going to show all the values there, but we would have u is less than -4, and u is less than 4. Okay, so open circle there, and that would also be shaded to the left. I'm trying to not overlap here, so. Okay, so now for this one, if it's and, we only want the overlap. Okay, so the only places that these two inequalities overlap is when u is less than -4. Okay, so we would have from -infinity to -4, and we would not include that -4. All right, now let me give you a couple things here. Again, if it's or, we take everything. If it's and, it's only the overlap. Okay, so for example, like we just had two that overlapped, and maybe I'm getting ahead of myself here, and maybe there'll be in a future one. But when these two overlapped, it was or, so we just took everything. Okay, everything that we shaded on that number line. Here it was and, so we only took the things that we went over twice. Okay, so anything less than -4, we went over twice. Okay, if we had it the other way around, so if we had something like u was less than -4 or u was greater than 4, so our -4 and our 4, so u is greater than 4 or u is less than -4, then we could have -infinity to -4. And this union means that we would also include 4 to infinity. Okay, because we would just include everything that we shaded. Oops, I should have an open circle there. Now, if we had u is less than -4 and u is greater than 4, there's no number that's less than -4 and greater than 4. So you use this notation that is called the empty set. Okay, there is no solution there. You cannot tell me a number that's less than -4 and greater than 4. Okay. All right, I'm going to stop there, and we'll do the last 4 videos in another, and the last 4 topics in another video.